Welcome back, grade 10s. All right, this is our last lesson, woohoo, of the unit. Okay, so let's just take a look here at some parallel lines and transversals. Okay, so that's something, again, that probably feels familiar to you from last year. I just want to remind you that the transversal line is a line that cuts kind of across two lines, other lines that are parallel. And a quick reminder that the symbol like this, like two little arrows, like that, are showing that both of these lines are parallel to each other. Okay, so we're going to see those kind of markings every once in a while, but usually I'll just state that these are parallel lines that we're looking at. Okay, so key things here: transversal that cuts across the two parallel lines. Okay, so that's what we're going to focus on in this lesson. All right, so we are going to look at 4 types of angle pairs based on that scenario of a transversal and 2 parallel lines. Okay, or possibly more than 2 actually, but primarily 2 parallel lines. Okay, so the first type is corresponding angles. Corresponding angles are a pair of angles that are in equivalent corners of the transversal diagram. So what I mean by that is that we have an angle here and an angle here, and we can see that if we take a look at this diagram that we have this angle or corner, pardon me, and then this corner, right? And so if we take a look at where those 2 corner angles are that I highlighted originally, this one and this one, we can see that in both cases they're in the top right corner of each intersection, right? So that is what I mean by in equivalent corners. Okay, and the other thing we know about corresponding angles is once we have those 2 angles in that equivalent corner of each part of the diagram, is that they are the same measure. Okay, so that's actually really important. So I'm just going to highlight that, and maybe worth it for you to highlight it as well. Okay, so that's that, and I just included another example over here. Okay, same kind of thing. Then we have this angle, and again, those are in kind of like the same corner of each intersection. Okay, so in this case, they're both in the top left corner, okay? But if we wanted to draw in another pair of corresponding angles, this and this would be the same, or we could say that this and this would also be the same as each other, right? So those 2 purple lines here and here, those show corresponding angles, both in the bottom left corner of the intersection, and here I'm showing the bottom right corner of the intersection, okay? So then this angle and this angle would be the same measurement. Okay, all right, so let's take a scroll down here and do a couple examples. So what is the measure of the indicated angle, so the question mark, in the first one, and then we're going to figure out in the second diagram how to solve for x. Okay, so we can see that this 133 is in kind of that bottom left corner of that intersection, and then the question mark is also in the bottom left corner of that intersection. Okay, so that means that we know that the question mark is equal to the angle given, which is in this case 133 degrees. Okay, so that's because we know that once we have equivalent corners, then they're the same measure. Okay, so they're the same number of degrees. So that's it for that question. Question or example 2, I guess, the second one here is a little bit more complicated, not by too much, but just kind of a little bit of extra knowledge there that we want to work with. Okay, so we can see that 60 is in that top left corner, and then 5x plus 10 is also in that top corner. So we know that 60 degrees is equal to 5x plus 10. And the reason that we know that is because we know that this angle is the same as this angle because they are corresponding angles. Okay, so now that we know that, then we can solve for x. Okay, and that's just using our algebra skills. When we do this, we don't actually even have to worry about the degree sign. Okay, we're just looking for what's x. So I'm going to subtract 10 from both sides. Okay, and that's going to give me 5x is equal to 50. And then last but not least, to get rid of the coefficient, I'm going to divide by it, right? So 5x divided by 5 will just give me x, and 50 divided by 5, pardon me, there we go, is equal to 10. So x is equal to 10, which is what the question asked us to find. So there we go. Okay, all right, so then moving on, the last thing I have asked us to do here is list all possible corresponding angles in this diagram. So I'm going to do some color coding here so that if you want to look back on this lesson, then it's easy for you to do so. Okay, so I'm going to start here with A. can see that A is in that top left corner of the intersection, and G is in the top left corner of this other intersection, right? So angle A and angle G are corresponding angle pair, okay? And then if I move down here to B, okay, so I can see that angle B is in the bottom left corner, and H is also in the bottom left corner, so that means that angle B and angle H are also corresponding angle pair. Okay, then if I move over here to C, which is in the bottom right corner, let's try that again. There we go. Then we can see that angle E is also in the bottom right corner, so that means that angle C and angle E are also corresponding angle pair. And last but not least, let's use the orange, I don't know, whatever. Then we have angle D here in the top right corner, and correspondingly, angle F. So there we go. Angle D and angle F are also corresponding angle pair. Okay, so that is that example. Okay, so we've listed all 4 of the pairs of corresponding angles, and we can move on to the next type. So the next one here is alternate interior angles. Okay, and so alternate interior angles are, let me just get this highlighted, there we go. Okay, so alternate interior angles are, the first thing that's really important is they're interior, okay, so they're inside, so they're going to be on the inside of the parallel lines, right, so they're going to be between the parallel lines and not outside of them, okay, so you're not ever going to find an alternate interior angle out here, or here, or here, or here, because those are all outside of the transversal and parallel line set, and we want them to be inside, hence the term interior. Okay, so that's the first thing. And then the next thing is that they're alternate, okay? And so alternate means that they're on opposite sides of the transversal line, okay? So wherever the transversal is, means one's going to be on this side and one's going to be on this side, okay? They're never going to be on the same side of the transversal. So if you take a look here at angles X and angle Y, then we can see that this X is on the left side of the transversal, so that means the other part of the pair must be on the right side, and this one is, that's good. And you can see that both of them are in between the transversal lines, so we know that then those are alternate interior angles. Okay, same logic here for the Y's. You can see that this is on the left side of the transversal, and therefore the other part of the pair must be on the right, which it is, and they're both in between the parallel lines. Okay, so that gives us the requirements fulfilled. A useful trick that I like to tell people is the Z trick. Okay, so if you want to determine whether angles are alternate interior angles, is to look for a Z shape in the transversal diagram. Okay, so for example, there, that's kind of a Z shape. I'm gonna maybe use a little bit of a darker color here. Hold on. Let's try that. Okay. So I can see that Z shape right there. I know that's kind of like, it's like kind of leaned over, you know, I know Z usually looks like that, but it's kind of tilted over, but that's okay, okay? And we can see that the angles are on the inside corners of the Z, right? So we can see that we have this corner and this corner, right? So kind of the insides of the Z, okay? That's what we're always looking for this trick. Okay, and same thing here, right? Again, I can see a Z here. This time it's backwards. That's also fine, okay? So you don't have to worry. The Z could be forwards, it could be backwards, it could be leaned over, it could be leaned over backwards. All of those things are okay. That's still the Z shape, okay? And once I have those established, like that Z shape, pardon me, then I can see that this is the inside corner and then this is the other inside corner, and voila, okay? So we found those inside corners of the Z, and that means that both of these are alternate interior angles. Man, tongue twister apparently. Okay, so let's take a look at this set of examples. So, which diagram displays alternate interior angles? Let's circle the correct diagram. So remember that alternate interior means that they need to be alternate, right? So they need to be one on the left, one on the right. You can see that's the case here, one on the left, one on the right, one on the left, and one on the right. Okay, so that is fulfilled. But we also know that we need to have interior angles, right? So they need to be inside, meaning between the two parallel lines. And we can see that these two are between, right? Those two angles are between these parallel lines, but we can see that this angle and this angle are outside the parallel lines, so that means that they are not interior angles, and so because of that, then this is the diagram that we're going to circle. That's the correct diagram. And just to think about that Z thing I was talking about, if you look here, we have a backward Z, and again, 2 angles in the corners, okay? So that's how another way to know that we have that alternate interior angle being fulfilled. Okay, let's determine the measure of the indicated angle below. All right, so this is the last thing to say about alternate interior angles, is that they are equal angles, okay? So that's their measurement is that they are the same measure, okay? And so because of that, we can say then that we can figure out this question mark. So we can see that we have a Z shape here, okay? And we have inside angle and inside angle, right? And so those are, again, between the parallel lines, and one on each side of the transversal, so these are alternate interior angles, and so then we can say in this case that the question mark is equal to 104 degrees because alternate interior angles are equal to each other. Okay, so now let's list the pairs of alternate interior angles shown on this diagram. So we did this diagram in the last example, but we are going to do this with alternate interior angles this time instead of the other type of angles like corresponding, which is what we did last time. All right, so just to remind us, oh boy, that's so messy, I'm sorry you guys, there we go. That is the transversal, and we need to have one angle on each side, and they all need to be between these 2 parallel lines. So knowing that they all need to be between the parallel lines actually rules out anything that's outside the parallel lines, right? Sorry, that was just my alarm. Okay, so we can cross out everything that's outside the parallel lines. None of those are contenders for alternate interior angles. Now, looking here, I can see a Z shape here. I know it's kind of wobbly, but you get the idea. Let's try that again. There we go. Okay, so there's that Z shape, and I can see that I have inside corner, okay? So angle B and angle F are alternate interior pair. And again, they're on opposite sides of the transversal inside the parallel lines. Okay. Then I can also see another Z shape here. Okay, it's okay again that it's backwards, it's totally no problem. And we have an inside corner and an inside corner that makes angle C and angle G pair of alternate interior angles. Okay, I'm actually going to stop this video here and then do another one in a second for the remaining part of this lesson, but I know this is getting long, and so you might not want to listen to the whole thing at one time. So if you want to just keep going, then just watch the next video after this. Okay, talk to you in a minute.